Is my screen visible?
Yes, sir.
Yes, sir.
Okay, yeah. Let us start with our class. Let me just summarize what we have learned in our previous class. We started with the introduction to engineering mechanics, and I told you what is the meaning of mechanics. And I also told you the three broad categories which are there in the mechanics. The one is the rigid body mechanics, deformable body mechanics, and the fluid mechanics. The rigid body mechanics is the one which we are going to deal in this course. The deformable body mechanics and the fluid mechanics are the one wherein they will be taught in the higher semesters of civil and mechanical engineering. But to study the deformable body mechanics and the fluid mechanics, rigid body mechanics is a at most important part. Now, rigid body mechanics has two more branches. The one is the statics and the one is the dynamics. Statics is the one which deals with the equilibrium of the bodies. Equilibrium is the one wherein the body could be either at the rest or it could be moving with the constant velocity. Now, the dynamic deals with the body which are having some accelerated motion. Statics is actually time independent and dynamics is actually time dependent. And we also learned about some of the basic quantities like length, time, and mass, which we are going to use in our whole course. But the length and the mass are the only one which we are going to use in statics. But time also comes into picture when we look into the dynamics part. And I explained you about the force. Force is nothing but a push or pull which is applied on the body. It could be like the two bodies which are in physical contact with each other will experience some force, and the bodies which are not in actually physical contact with each other will also experience some force. The first one where the physical contact is there, it could be like you applying some force on anyone or anything. That could be a physical contact force, and the non-physical contact force is like a electromagnetic force, gravitational force, and magnetic force. Many are there. And to represent a force, you actually need three things. That is the characteristics of a force. One is the magnitude, like you need to mention how much is the force. Also, you need to mention the direction of the force, in which direction it is being applied. Also, you need to mention the point of application of the load, like where you are actually going to apply the force. The force, we give the symbol capital F, and the SI unit is newtons. It is represented by the symbol capital N. The base SI unit is kg meter per second square. Okay, these are all the things which we learned in our previous class. This was just a glance through regarding what we have learned in our previous class. And I told you we need to in the previous class, like I told you how what will be our next things. Our next things will be like idealizations. Models or idealizations are used in mechanics in order to simplify the applications of the theory. Like if you don't make any assumptions or any simplifications before applying any theory in the practical field, so it becomes very tedious. So we need to make some idealizations or some assumptions, or I can call some models, to apply the theory in practical. And here we will consider three important idealizations. The first one is actually called as a particle. Now, what do you mean by particle? A particle has a mass, but size that can be neglected. When I mention any a particle, it doesn't mean that it is not having shape and size. Uh, there will be some size to the particle, but that can be neglected, but it has some mass. For example, what I can give is the size of the earth, okay? The size of the earth is insignificant. Okay, it is insignificant compared to the size of its orbit. Like the earth is revolving, rotating in its orbit. Okay, so but the size of the earth is compared to its orbit is very negligible. Therefore the earth can be modeled as a particle when studying its orbital motion. Like when you want to study the orbital motion of the earth which has having some shape and some mass, but you can treat it as a particle when you are actually studying the orbital motion of the earth. This is the simplest example what I can give. When a body is idealized as a particle, the principle of mechanics reduces to a rather simplified form, since the geometry of the body will not come into picture. Okay, so it will be very useful for you in the analysis kind of problems. So you also always need to mention something as a particle which has some mass, but the size of that particle can be neglected. This is the first idealization what we can do when applying the mechanics to the practical applications. Now the next one is rigid body. Now what do you mean by rigid body? A rigid body can be considered as a combination of large number of particles. Okay, it could be a combination of large number of particles. A particle, I told you, what do you mean by particle? Now the rigid code body could be considered as a combination of large number of particles in which all the particles remain at a fixed distance from one another, both before and after applying the load. Now I can just give you one simple thing, like something like this. I can give you an example regarding the rigid body. Now I can consider this as a rigid body which is comprised of a large number of particles. Okay, so when you try to apply some force on this rigid body, for example, if I take two particles which are at some distance from each other, okay, if I take these two particles, even after applying the loads, okay, the size, shape and the distance between these two particles will remain same even after the applying the load. That is, before applying the force and after applying the force, the what I can call the distance between those particles will remain same. They will not change at all. So such kind of a body, I can call it as a rigid body, right? Now coming to the concentrated force. Okay, so what do you mean by actually the concentrated force? A concentrated force represents the effect of a loading. Okay, load, I can say it as a force. A concentrated force represents the effect of a loading which is assumed to act at a point on a body. For example, if I take, say, this is a road, right? And this is the wheel of a vehicle, right? So I can assume that this total load of this wheel is getting concentrated at a particular point on the road, maybe something like that. Then I can assume that the load from this wheel on this road can be considered concentrated at a particular point. Now this is a section. If I try to draw the plan, okay, the wheel could be something like this. So this could be the point where the total weight of this wheel is getting concentrated at a particular point. Now this assumption is also very, very important to apply the uh, theory of mechanics in the practical applications, right? So students, are you having any doubts in these three parameters like particle, rigid body and concentrated force?
Sir,
Yeah. Yes.
so please repeat concentrated force once again, sir.
Okay, I will just repeat the concentrated force. A concentrated force represents the effect of a loading which is assumed to act at a point on a body. Okay, we can represent the load by concentrated force provided the area over which the load is applied is very small compared to the overall size of the body. Okay, for example, the same example I'm going to give you here, right? Please mute your audio.
ಫಿಸಿಕ್ಸ್ ಒಂದು ಚಾಲು ಆಗೈತಿ
Someone is disturbing. Please mute your audio. Okay, right. Uh, for example, I can give you this kind of an example wherein if I take this wheel, okay, I'm taking this wheel and the wheel is actually resting on the ground, or I can say it is on a road. Now, when the whole load or I can say whole weight of this wheel is getting concentrated at a particular point on the road, then I can assume that the load from this total wheel can be taken at a particular point. So this could be the load, and this load, this force, I can call it as a concentrated force provided. Okay, there are some conditions. The area over which the load is applied is very small compared to the overall size of the body. Now here in this case, if I just try to draw the plan, means from top view, this is your wheel, okay, and only this much of area is the one which is in contact with the wheel. That is, this much of area is in contact with the wheel, that is area of the road. This much of area of the road is in contact with this wheel. So I can say that this much of area is very small compared to the overall size of this wheel. So then only I can say that the total load of this wheel is getting concentrated at this particular point. Now if I want to give you a reverse kind of example of this, suppose say uh, I can say like something like this. Okay, so say this is some surface, or say this is some ground. Okay, now suppose say few people are standing like this on this ground, very close to each other. Okay, very close to each other, some hundreds of members are standing on that. Okay, now let me take that each person is having 1 kg of weight. This is just for an example. Okay, each person is having some 1 kg of weight. So 100 people means how much is the total load? So I can say it as a 100 kg, right? Okay, 100 kg. But when you see here, the contact between each person and the surface, okay, is actually not a small one. Maybe they have occupied from this to this much of space, this to this much of space, this much of space they have occupied. So in this case I can't say that the total load from all these 100% is acting at a particular point. No, it is not possible, because the load is actually distributed, right? So this is not an example of a concentrated force, where the contact area is not small as compared to the size of the load, right? But here I can consider that one. Am I clear?
Yes,
Yes,
sir.
sir.
Thank you, sir.
Yeah. Okay.
Yes, sir.
Right. Now, once you are done with this basic idealization, this is a very important one. You can just note down this basic idealization is a very important concept, because most of the time in most of the question papers, they have asked this for maybe around 6 to 8 marks. They will ask you like uh, brief or explain about the idealizations made in the engineering mechanics. So in that case, you have to explain particle, rigid body and concentrated force. If you write this much only, no, I'm sorry, you will not get any marks. At least you should give some example to each and every idealization. Like for a particle, I gave you an example of a Earth revolving in its orbit. Now for rigid body, I gave you this kind of an example. Okay, and for a concentrated force, I gave you an example of a load of wheel on the road. So if you try to give this much of example with the figures, okay, this is very important. With the neat sketches, if you try to explain that, so 99% you will get full marks, right? So explaining the things with the figure is much more appreciated than writing some 1 or 2 pages of theory. Am I clear? Right. Okay. Right. Next few parts are very simple one, which you have already learned. So I will not waste much time in all these things. So we also need to study the Newton's laws of motion. The engineering mechanics, whatever we are teaching now and whatever you are studying now, it is totally formulated based on the Newton's laws of motion. The first law. Now the thing is here, the whatever law statement you have heard earlier in your PUC 1 and 2 may be different from this one, but the meaning remains same. The statement what I'm going to give for first and second and third law is uh, totally correlated with the particle and all those things. Let me just read out the first law. A particle originally at rest or moving in a straight line with the constant velocity tends to remain in this state provided the particle is not subjected to an unbalanced force, right? So I told you here I am taking the name of particle, okay, which is at rest or moving in a straight line with the constant velocity. Means I really mean that the particle is in equilibrium, right? The particle is in equilibrium. It will remain to be in equilibrium provided the particle is not subjected to an unbalanced force. So this is your first law. Now second law goes like this: a particle acted upon by an unbalanced force F, okay, experiences an acceleration A that has the same direction as the force, and the magnitude is directly proportional to the force, right? For example, if F is the force which is applied on a body of mass m, and if it moves with the acceleration a, then I can say that the force which you have applied on the body of mass m is directly proportional to the acceleration. So I can give this equation, that is F equal to m into a, where m represents the mass, a represents the acceleration, and F represents the force, right? Now the third law, the mutual forces of action and reaction between two particles are equal and opposite, right? So I hope you don't have any difficulty with this Newton's laws of motion, because right from your school only you have been taught about these Newton's laws of motion. So you should not face any difficulty with this. You have any queries?
Sir, in case of particles, why size should not be taken? Could you
Okay.
re-explain it?
Yeah, that's actually a good question. Right. When you take the particle concept, I told you particle has a mass, but the size can be neglected. Now, why the size can be neglected? Right. I gave an example of the Earth, which is revolving or which is moving in its orbit around the sun. Right. Now, when you try to study the orbital motion, right, orbital motion of the
Yes,
Earth,
sir.
and when you take the effect of size of Earth also into consideration while studying the orbital motion, so you may not end up with the correct answers or correct results. The shape or size of the Earth may affect your study of orbital motion, right? But why you have to actually neglect that? Because the size of the Earth is very negligible compared to its orbital motion. So that's why we actually neglect the size and shape of the Earth when we are studying the orbital motion. So if you consider also, no issue with that, but you are making your calculations or you are making your study much more complex than what is required.
Okay, sir. Thank you.
Okay, just to avoid all these complications or just to avoid unnecessary calculations, we usually neglect the size of the Earth. If you consider also, it will not matter at all. If you don't consider also, it will not matter at all. But if you don't consider, you will end up with the simple analysis and simple numerical things. So that's why we try to neglect the size and shape of the Earth, or size and shape, and we consider it as a particle.
Okay, sir.
Yeah.
Thank you.
Okay. Okay. Yeah. So you have any doubts in these Newton's laws of motion?
No, sir.
Yeah, there is one more law called Newton's law of gravitational forces. I'll not take much time on that, or I don't want to touch that part also. I have written all those things in my notes, and you have already studied that one. So I'm not going to just deal with the Newton's law of gravitational acceleration. Is that okay for you?
Yes.
Is that okay?
Yes, sir.
Yes, sir.
Yeah,
Yes,
okay.
sir. Yes, sir.
So that
Yes,
we
sir.
can quickly move to our actual things, right?
Yes, sir.
Yes, sir.
Yeah, okay. Now, after this, we need to have some units of measurement, which are very, very important in some way or the other dependent. Now, the SI unit for length is in meter, time is in seconds. This M and S are in small. You should note down that also. Now, mass we represent in kg, K and G both are in small. Force in newtons, and N is capital. And I told you, what do you mean by one force or 1 Newton? 1 Newton is the force required to give 1 kilogram of mass and acceleration of 1 meter per second square. This I think you know already. That's why the base SI unit of force is kg meter per second square, right? And the acceleration due to gravity G is represented in terms of 9.81 meter per second square. Okay, then there are also some prefixes what we usually take when a numerical quantity is very small or very large. The unit used to define its size may be modified using a prefix. When you say giga, it means 10 raised to 9. It is represented by the term G. When you say mega, it is 10 raised to 6, represented by the term capital M. When you say kilo, it is 10 raised to 3, represented by the term K. Okay, have any queries in this?
No, sir. No, sir.
Okay,
No.
I'm moving a little bit quick in all these parts because these things you have already learnt, right? Okay, now coming back, now hence now next are the things which are little new to you maybe. So I will go little bit slow. Now we will come back to our main agenda. That is, first let us study regarding force. Okay. Now, force, I already explained you, force is considered as a push or pull exerted by one body on the another. The force exerted by one body and the another, maybe it might be a physical contact between the two bodies, or it cannot be a physical contact like it is in terms of magnetic force, gravitational force. But those kind of forces we are not studying here. We are studying only the force between two bodies which are in physical contact which with each other. Now there are some principles which you need to study in terms of forces. The first principle is actually called as superposition of forces. Have you heard about this, students?
Yes.
Superposition of forces. Have you heard about this, students? Anyone? No?
No, sir.
Okay, let me explain that. Now, the principle is very simple. The principle of superposition of forces states that the combined effect of forces for the combined effect of force system acting on a particle or a rigid body is the sum of effects of the individual forces. Now let me explain you what is the meaning of this one. Now for example, if I take, let us say I will take one body here, okay, which is having a mass m, right? Now what I will do, I will put some force F1 on this body. Now because of this force, the body will move by a certain distance. Let that distance be d1, right? Now I will take the same body having same mass, the same body which I used earlier. I will take same body. Now instead of now say F1, let me apply a force say F2. F1 and F2 are not equal now, right? Now because of this, the body experiences some displacement and it moves by distance d2, right? Now what is the meaning of principle of superposition of forces? It is very simple, okay? If you take the same body of mass m, and if you try to apply the those same forces F1, whatever you had applied earlier, and F2, whatever you had applied earlier, now the body will experience the same effects. All right, okay, I will explain you. Now you now see these figures and I will explain you the, I will give you the statement so that you can correlate. Now the principle of superposition of forces states that the combined effect of force system, the combined effect is F1 and F2, the combined effect of force system acting on a particle or on a body or a rigid body is the sum of effects of, okay, is the sum of effects of individual forces. Can you just correlate, students?
Yes, sir.
Is that okay?
Yes.
Yes,
Right?
Yes,
sir.
sir.
I will repeat once again. So the principle of superposition of forces states that the combined effect of forces, that is F1 plus F2 in this case, okay, the combined effect of forces, what is the effect of these two forces? The effect of these two forces is to move the body through some distance d1 plus d2, right? The combined effect of these two forces acting on a body or a rigid body, okay, is the sum of effects of individual forces, right? So this is very simple to understand. So this is called principle of superposition of forces. Is that clear?
Yes, sir.
Yeah.
Yes, sir.
Yes,
Right.
sir.
Now, when I'm going to apply these principle of superposition of forces, I will come to that part when we take up some numerical examples, maybe in the later stage, right? But at this point of time, you should understand what do you mean by principle of superposition of forces. Now, also we need to understand there is one more very, very important principle. It is called as principle of transmissibility. Principle of transmissibility of forces. Okay, let me read out you the statement. You may not understand at the first instance itself, but let me read out that part. Okay, so that I can explain you with some example. Now the principle of transmissibility of forces states that the point of application of a force can be moved anywhere along its line of action without changing the external reaction force on a rigid body, right? Any force that has some magnitude and direction and which has a point of application somewhere along the same line of action will cause the same effect. Therefore, the points of application of force may be moved along the line of action to simplify the analysis on a rigid body. Okay, I know most of you have not understood what I told. Let me explain you that with a example. Let me take one, say, rigid body. Let us say that this is a rigid body. Okay. Now, next what I will do, I will try to apply a force, say F, on this rigid body at this point, right? I told you, so that you need three things to represent a force. First is the magnitude. In this case, it is F. Second is the magnitude. Okay. Second is the direction. So this is the direction. And the third is the point of application. So the point of application is this one. Now, what I will do along this force, I will draw a dotted line, something like this, right? Let me, it is not a straight line, right? Okay, so this is a dotted line which I extend this side and that side. Okay, so this dotted line is actually called as line of action of force. This dotted line is called as line of action of force. Okay, right? Now let this point where the force is being applied, let it be point A, right? Okay, now what I will do, I will take the same rigid body. Okay, so it doesn't look same. Yeah, this almost looks same, right? Okay, I will take the same rigid body, right? Now what I will do, I will draw this line of action where it was there already. This is the line of action. Now instead of applying the force at point A, or means in this side, let me try to apply the force somewhere here. Let me call this as, say, F, right? This is line of action. I will name it by the term LOA, line of action of the force. Okay, so this is force F. Now in this case, I can say that this system and this system both are equal to each other. Do you agree with this? Students, are you agreeing with this?
Yeah. Yes, sir.
And I also need to tell you that this force F and this force F are equal, but the line or the point of application of the force is different. In this case, I had applied the force at this point, but in this case, I'm applying the force at this point. Let me say this is point B. Do you agree that both the systems, that is on the left hand side and on the right hand side, are they equal or not?
No, sir.
Okay, anybody who want to say no? They are actually equal. This is called the principle of transmissibility of forces. Now let me read out that statement now here once again. Okay, now see the figure and listen to the statement. Now the principle of transmissibility of forces states that the point of application of force can be moved anywhere. Okay, the point of application of force, this is point A, can be moved anywhere along its line of action. Okay, can be moved anywhere along its line of action. Okay, line of action without changing the external reaction force on the rigid body. I mean to say, without changing the direction of the force on the rigid body, right? Any force that has the same magnitude and direction and which has the point of application somewhere along the same line of action will cause the same effect, right? For example, now let me explain you. Now suppose say I'm applying this force at point A. So this dotted line represents the line of action, right? Now this point B is on the same line of action of this one, means this point B is somewhere here, right? But now what I'm doing, instead of applying the force at point A, I'm trying to apply the force at point B now. Okay, but I'm not changing the magnitude, neither I'm changing the direction, right? So in that case, I can say that whatever effect is produced by this force F on this rigid body will be same as that of this force F at point B on this rigid body. But what I should not change, I should not change the direction of force. Okay, it is same. I should also not change the magnitude of the force. Yes, that is also same. Also, I should not change the force, or I should not put the force away from the line of action. So if I do all these three things, I can say that the effect produced by the system on the left hand side is equal to the effect produced by the system on the right hand side. So this principle is called principle of transmissibility of forces. Are you clear?
Yes, sir.
Any
Yes, sir.
doubts? Any doubts you have, students? Please don't keep any doubts with you. Let it be a silliest of the silliest doubt. Get it clarified. Because we are going to use all these things in our numerical examples. All these principles we are going to use in our numerical examples. No? Okay, right. So these are the two very important principles what you should know in case of force. That is, the first one is the principle of superposition of forces, and the second one is the principle of transmissibility of forces. Now next, let us just discuss on some system of forces, right? Just a minute, students.
Okay.
Yeah, students. Okay. Now let us discuss about next some of the important point, that is system of forces. Okay. I told you the force mm, need to have three important things: magnitude, direction, and point of application, right? Maybe I can just represent something like this. Okay. Let me apply a force, something like this. Let me take some different color here. Yeah. Okay. Let this be a force. Say this force is, let us say it is 4 kilonewtons, right? And let this angle be say 30 degrees. Let this axis be x and let this axis be y, and let this point be point A, right? Now I can say that the first parameter, that is magnitude of the force, is 4 kilonewton. Second parameter is the direction. So I can say that the force F is at an angle of 30 degree with respect to x axis. And the next point, I can say that the point of application, that is the force is getting acted at point A. So these are the three characteristics which you need to mention whenever you try to mention a force, right? Next thing, there are some system of forces. Okay, force system. Let me just write down that. Okay, now what do you mean by actually force system? Force system is the one which is having more than one force. Okay, whenever there is more than one force in a system, then that kind of system is called as a system of forces or a force system. Simply a force system or system of forces. Whenever there are more than one force. Now we have some broad categories here. Let me just introduce to them you to those categories. The first category is coplanar, and the second is non-coplanar. Okay, right. Now, what do you mean by coplanar? Coplanar is the one wherein all the forces lie in the same plane. Okay, when all the forces lie in the same plane, so those kind of force system we call it as a coplanar. Now, for example, this is my screen. Okay, if I try to represent the forces something like this is one force. Let us say F1. This is one force. Let us say F2, and this is one force. Let us say F3. Now you can see that all my forces F1, F2 and F3 are on my screen. Okay. Now the screen is a 2D, or I can say it is a plane. So these forces I can call it as a coplanar forces. Now for example, let me try to draw a 3D figure here. Let us say this is X axis. Let us say this is Y axis. And let us say this is Z axis. Now if I try to represent, say along X axis, I have a force F1. Along y-axis, I have a force F2. Along z-axis, I have a force F3. Now you can see that F1, F2 and F3, all these three forces are not in a single plane, right? F3 is out of plane. So I can say that the system of forces comprised by F1, F2 and F3 are actually non-coplanar, and these are or I can say they are coplanar, right? Okay, now inside coplanar, we have few more things like collinear. Okay, next is parallel. Okay, next is concurrent, and the last one is non-concurrent. Okay, in non-coplanar also we have like parallel. In this we have concurrent, and in this also we have non-concurrent. Okay, I'll explain each and every force one by one. But till now, whatever we have studied, are you okay with that, students? Any doubts you have?
So,
Yes, yes.
can you explain the non-coplanar once again?
Okay, non-coplanar. Simple. Have you understood about coplanar?
Yes, sir.
Yeah, coplanar force system is the one wherein all the forces lie in a single plane. Okay, all of them lie in a single plane. For example, let me just give you this kind of an example. What I will do, I will draw one plane here. Okay, I will draw one more plane here. Can you imagine this as a 3D? Can you imagine in this in a 3D
Yes, sir.
form? Yeah. Okay.
Yes.
Okay. Now let this be is the one plane. This is one plane, and this is one plane. Now in this plane, let us say that there are some forces F1, F2, and say this is F3. Now in this plane, there are some more forces like say F4, F5 and F6. Now this F1, F2, F3 are on this plane. Okay. F4, F5, F6 are on this plane. Now if I try to say the system of forces comprised from F1 to F6, they are actually non-coplanar forces. Why they are non-coplanar forces? Because all the forces are not in a single plane. F1, F2, F3 are in a one plane. F4, F5, F6 are in one more plane. Now, if I say F1, F2, F3, they are coplanar, and F4, F5, F6, they are coplanar. Have you understood?
Yes, sir.
Is it
Yes, sir.
clear?
Yes,
Am I
sir.
Yeah, okay. So any other doubts you have?
So what about transmissibility of forces? In that case, anything from if one place a point is force is applied, and from another point force will come out.
No, I didn't understood your question.
So force is applied on A, then the force will come out from C. Then
No, it is not like force coming inside A or it is going out, right? The force is being applied at any point on the line of action of the force, provided
okay,
you don't change the magnitude, provided you don't change the direction, and provided you are not applying that force anywhere away from the line of action. Then only it is principle of transmissibility of forces. It is not like coming in or going out. No, don't think like that.
okay, sir.
Yeah.
Thank you, sir.
Yeah. So if you are not having any doubts, let can I proceed and explain you about what are all these coplanar, non-coplanar forces?
Yes, sir.
Yeah.
Yes,
Okay.
sir.
Yeah.
Yes, sir.
In our course, we are studying only coplanar forces. Non-coplanar forces, or I can say them as a 3D forces. The forces which are in 3D. Okay. Non-coplanar forces are the one which are in 3D. So that we are actually not studying. You are studying only the coplanar forces, right? Okay. Let me start. Let me start with the collinear forces. Please mute your microphones. Please, I request to mute. Okay. I'm requesting again, students, please don't unmute unless I say. If you're speaking, okay, if you're trying to answer any question, unmute it, speak, and then immediately mute it. Right? Okay. Let me start. Now the collinear forces. Now what do you mean by collinear forces? When line of action of all the forces of a system act along the same line, such a system is called as a collinear force system. Now let me just explain you that using a numerical example. Okay. Let us say I will draw one dotted line here. Okay. Let me mark some forces on this dotted line. I will mark first force, say let it be F1. I'll mark another force. Let this be say F2, and I'll mark another force. Let this be say F3. Okay. Now, if you see the line of action of force F1, the line of action of force F2, and the line of action of force F3, all are coinciding with each other. Yes or no?
Yes, sir.
The line of action of force F1, F2, and F3 all are actually coinciding with each other. then
Yes,
these
sir.
then these type of forces, the system formed by these type of forces are called as collinear forces. Have you understood?
Yes, sir.
Okay, when the line of action of all the forces in a system, okay, act along the same line, then such kind of system is called as a collinear forces. You can see in the name itself, you can see co means same, linear means that line. Okay, the collinear forces, I can say that. So forces F1, F2 and F3 all are collinear forces. Are you clear?
Yes,
I will
sir.
I will go for
Yes,
next one.
sir.
I will go for next one. Parallel forces. Now the name itself suggests you. Okay. Can anybody just have a wild guess? What do you mean by parallel forces?
Forces which are acting parallelly to each other.
Okay, you actually need to
Fully.
be you you actually need to be more specific. Like you should say when the line of action of all the forces are parallel to each other, such kind of force is called a parallel force. Are you clear?
Okay, sir.
Yeah. So let us say this is F1, say F2, say F3, say F4. Okay, F4, F3, F2 and F1. Now the force system formed by force F1, F2, F3, now they are actually parallel forces because the line of action of each and every force is parallel to each other. Now they are specifically called as like parallel forces. Why? Can anybody?
It's acting in same direction.
Yes,
All
correct.
in
Okay.
same direction. Same
Yes,
direction.
yes. Like parallel forces. Okay. There could be another system of forces in parallel, which are actually called as
Unlike.
unlike. Okay, you can see here. So this is say F1, F2, F3, F4. Now they are called as unlike parallel forces because the direction is not same as the other forces, right? Now let me come to the next part. So we are done with collinear and parallel. Let me come to the next part, that is concurrent. Concurrent. Okay, let me explain you that. Okay, when the line of action of all the forces pass through a common point, okay, when the line of action of all the forces pass through a common point, such a system is called as concurrent force system. Let me just give you example for that. Let us say this is force F1. Okay, let this be having some line of action, something like this. All right, uh, let us say this is force F2. Let us say this is force F3. Okay, let us say this is force F4, right? This is F2, F3, and say this is F4. Now if you try to extend the line of action of each and every force, you will see one thing, what will happen there. Can you see when I try to extend the line of each and every force, the line of action of each and every force is passing through a common point? Yes or no?
Yes, sir.
Okay. Now
Yes, sir.
Yes,
this,
sir.
yes, now this kind of force system is called as a concurrent force system. Clear? Concurrent force system. Now there is another force system which is called as non-concurrent. So what could be that?
Different points.
Yeah, I can say that it is not like a different points. I can say that when the line of action of each and every force is not passing through a common point, then such system of forces is called as a non-concurrent force system. Let me just give you an example for that also. Let this be force F1. Uh, let this be force say F2. Let this be force F3. Okay. Let this be say force F4. Now, if you try to extend the line of action of each and every force, you can see that the line of action of each and every force is not passing through a common point. Then this system of force is called as non-concurrent force system. Are you clear, students?
Yes, sir.
Yeah, I told
Yes,
earlier
sir.
also we are studying only the coplanar. Non-coplanar force system we are not actually studying, so we'll not worry about this non-coplanar. So this is the coplanar force system. So let me just stop here, and in my next class I'll be dealing with the next type of study called resolution of forces and all those things, right? So you have any doubts till now, students?
No, sir.
No, sir.
So, no,
No?
sir.
No, sir.
Sir.